equation notes on graphing linear equations. Now we're going to go beyond slope-intercept form, and we're going to use a table of values. I know at some point in middle school you learn how to take numbers from a table and plug them in to find answers. So in this problem we have y equals 2x plus 1, and these are the numbers they are wanting you to plug in for x. So I'm going to do the work here below. If I were to plug a negative 2 in the place of x here, okay, because these are your x values, you would take 2 times negative 2 plus 1. Okay, so you can do the work, or you can type that in your calculator. But negative, that comes out to negative 4 plus 1 equals negative 3. So I'm going to take this answer and I'm going to put it in the table. So when I plugged in a negative 2 here, I got the answer of negative 3. And then you would just go to the next number. The next value for x they want you to plug in is negative 1. So 2 times negative 1 plus 1. Again, we're just replacing the x value here with whatever it tells me in the table. So 2 times negative 1 is negative 2 plus 1. Negative 2 plus 1 is negative 1. So when you plug in a negative 1, the answer comes out to negative 1, because this is what y equals. Okay, let's try this one. 2 times 0 plus 1. Well, we know 2 times 0 is 0, plus 1 equals 1. Okay, let's try the next one. 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. Plug in 2. 2 times 2 plus 1. That's 4 plus 1 equals 5. Okay, I want you to look to see, can you tell a pattern in these numbers? Negative 3, negative 1, 1, 3, 5. If you look, each time this is going up by 2 places. So if you do the first couple and you can see the pattern, or these numbers over here are going up the same amount each time, then you can always fill in the pattern. These things represent ordered pairs, because in an ordered pair you have x and then y, and that's how the two columns are set up. So this is the ordered pair, negative 2, negative 3. So to graph that point, this is your x-axis, this is your y-axis. You go left to negative 2 and down to negative 3. Okay. Then I'll graph the next point. Negative 1, negative 1. 0, 1. 1, 3. And 2, 5. If you filled in your table correctly, these points on here should make a straight line, because this chapter we're doing linear equations, which make straight lines. You'll notice on the next one, it's not y equals. So what I would suggest doing on this question is getting y by itself, like getting it to slope-intercept form, so that when you plug the numbers in, you just get your answer for y. So let's take this problem here, and I'm going to work it out up here at the top. If you were going to get y by itself, you would want to move the x first. And then you divide by the number in front of the y. So negative 9 divided by 3 is negative 3x. 12 divided by 3 is positive 4. Alright, now this is the equation I'm going to use to plug the x values into. So I'm going to circle that up here, box it in. That's the equation I'm going to use to plug in my x values. So the first x value they want to plug in, right here now is my x. I'm going to replace the x with these numbers. So negative 3 times negative 2 plus 4. That's 6 plus 4 is 10. Okay, so I'll put that in the table. Next actually plug in a -1. I start writing the answer. Negative times negative is +3 plus 4 is 7. -3 times 0 plus 4, that gives you 0 plus 4 is 4. And if I'm working too fast, pause the video, try plugging them in, see if you get the same answers. So the next value is plug in 1. -3 plus 4 is a +1. Hopefully you guys are starting to see a pattern in my answers over here. They seem to be going down by 3 each time. And if you look at the slope of your problem, it's -3. So if you remember how to graph with slope, you would go down 3 over 1. And that's what's happening every time our y values are going down 3. The last number we had to plug in is 2. So -6 plus 4 is -2. So now our goal is to take these ordered pairs and graph them in the table, or graph them on the graph. It's your x-axis, your y-axis. I don't think I have 10 lines here. 3, 4, 5, 6, 7. Actually, I only have 7. So you can have two options here. If this was like an evaluate or EOC situation, I would probably just make these numbers go by 2s. Like 2, 4, 6, 8, 10. I would have plenty of room then. But as far as I'm concerned, in this one I'll let you either put that off the graph or just skip that point. So I'm going to probably just skip that point for right now, because this would be 7, 8, 9, 10. So we could put it over here. But like I said, it's kind of not really on the graph. Other option, to go by 2s. Okay? So the next one is -1, 7. That would be right at the top of my graph. 0, 4. 1, 1. And 2, -2. And I draw a line through those points. One thing you can always double check to see if your table makes sense. Notice, is the y-intercept at 4? Yes. Is the graph going down 3 over 1? Yes. So I know that even using the table version or the slope-intercept form version, these two should match. Okay? Alright, let's do x and y intercepts. Alright, so on the other page, back over here, it says standard form. If it's x and y, it says substitute y equals 0 to find the x-intercept. Okay, so we're going to take this equation and we're going to substitute in y equals 0. So -3x plus 0 equals 2. And you want to solve for the x then. You would minus the 0 to the other side. 2 minus 0 is 2. And then we're going to divide by -3. So -2 divided by 3, or 2 divided by -3 is -2/3. So sorry, that's x equals, that was an x. Okay, so my x-intercept is at -2/3, comma 0. So it's kind of up to you what you want to go by. Technically, normally I go by 1s, but these are really small. If you go just by 1s, -2/3 is going to be like right here. On that line between 0 and 1. Okay, so that was the x-intercept. Now we're going to let x equal 0. So if x equals 0, this becomes 0 plus y equals 2. So the point for the y-intercept is 0, 2. if I were to draw a line through that 2 points. So step 1 says let y equals 0, plug in a 0, solve for x. Put that number on the x-axis. If you let x equal 0, you're solving for y, and put that number on the y-axis, and then you connect the 2 points. Alright, let's look at this one. If y equals 0, if the y is gone, because 5 times 0 is 0, so I'm going to say if y equals 0, then there's no y's in the problem. You get 2x equals 15. Divide by 2, divide by 2. The x would equal 15 divided by 2. It's 7.5. Let's double check. Okay, so at this point, the x-intercept is going to be 7.50. And then, draw a line here. If x equals 0, that means there's 0 x's in the problem. Now we would have 5y equals 15. So y would equal 3. You divide by 5, divide by 5. So my y-intercept number would be 0, 3. Because remember, this is your x value, this is your y value. So if x equals 0, then we got the answer of y equals 3. So my x answer was 7.5. 7.5 means I'm going to be just off the graph. And 0, 3 is right here, and then we would connect those 2 points. So that is x and y intercepts. You find the x value, plot it, find the y value, plot it, and then draw a line through those 2 things.